Let's send a weather balloon into space. Or at least the stratosphere. Alright, if you're interested in how we did this, stay tuned for the next minute or so. If not, just skip ahead to the good stuff. Let's first talk about supplies. What do we need to make this happen? Well, a couple things. We have essentially a cooler. It's basically an insulated box, styrofoam box. You can get this off Amazon or uline.com. We punctured a couple holes in either side of it in order to drop our GoPros in. Now we had 2 GoPros. These aren't GoPros, they're essentially knockoffs. It all depends how much money you want to spend on this project. These ended up working out fine. The other thing that helped was we had a battery that was an external battery pack. I think that gave them some more life. What's inside the box is a few bolts to hold the parachute on. We had it tied to 4 bolts, and then it was going up to the parachute and then eventually up to the balloon. So you want the bolts leading to a line up to the parachute and then eventually up to the balloon. That way when the balloon bursts, it's above the parachute and it floats down. That's that part. You need a scale. The scale is going to help you measure the weight of your payload. It's also going to help you measure your positive lift. You need to know your positive lift because you need to know how fast your payload is going up, and ultimately that'll help you calculate your burst altitude. Secondly, you need a balloon filler. Now this thing is something that we did not build ourselves. You can get this off of a website called the-rocketman.com. All of this will be in the show notes, so check that out. Duct tape, always need duct tape. Use duct tape in the end to just seal up the payload box. And then tracking the thing, we used a Spot Gen 4. So that worked really well and was able to allow us to track it while it was in the air and as it landed as well. Lastly, toe warmers or hand warmers. It gets mighty cold up there, negative 60 degrees. This helps reduce the battery wear on the cameras. Those are the supplies you need to make this happen. Okay, a couple websites that can be helpful, and again, this will be in the notes below. One to track where this thing is going to go. So that is predict.havhub.org. Now this will track based on the weather patterns, based on the jet stream, etc., the direction that the payload is going to go. Now ours was sort of accurate. It probably fell within 40 or 50 miles of where the website suggested it would. At the very least, it got us going in the right direction. Another helpful website is highaltitudescience.com. This will help you figure out your burst altitude and it'll help calculate ascent rate. Everything that we've read suggests that you want the ascent rate to be something like 5 to 6 meters per second. If it's too fast, it won't travel as far, the payload won't travel as far, which can be nice because you don't have to travel as far for recovery, but your altitude won't be as high. If it's too slow, you might get a higher altitude, which could be cool for video, but you might have to travel super far. In the end, we had to travel about 130 miles to recover our payload. Those are a couple tips. Check them out in the notes below.